So for this section, we're going to factor and solve quadratics, just like we have been. And this time quadratics are going to be in standard form, and we'll talk about what that is. We're going to use the AC method this time. When we're doing this, we're going to look for and express regularity in repeated reasoning. So this is when we're looking for patterns and we're figuring out how to shorten those patterns just a little bit. So there's going to be a pattern to what we do. We're going to be going through steps. And as you do this, you're going to get better and better at it, and you're going to be able to kind of shorten some of the steps just a little. So to warm us up a little bit, let's factor this problem. So this is a 4-term polynomial. And so with 4 terms, we use factor by grouping. And so the first 2 terms of this, my GCF is x. And when I factor that out, I'm left with 5x plus 3. And then for the second 2 terms, my GCF is 3. And when I factor that out, I'm left with 5x plus 3. My 2 binomials are the same. So I can go ahead and factor them out. And I'm left with x plus 3. And that is my factored polynomial. Those are my 2 binomials that I created. So when I talk about the standard form for a quadratic expression, it looks like this. We have ax squared plus bx plus c. And so looking at this, a, b, and c are standing for numbers. And so when we have an actual standard form quadratic, we're going to have numbers in those places, and we'll just have the x squared and the x in there. And so when we have quadratics that are in this standard form with the trinomial, then we are going to use this AC method. So this AC method, we have a few steps that we are going to go through. The first step is we're just going to identify what A, B, and C are in that standard form, and then we're going to identify A times C. So we're going to identify A, B, and C, and then we're going to identify A times C. So A and C are going to be numbers, so when we multiply them together, we're just going to have a different number. Our second step is we're going to think through, or we're going to write out all the factors of AC. So at least for the first couple problems, we're going to be writing them out, and then as you get more used to this and you get more practice, you're going to get to a point where you'll be able to just think through those factors. So we're going to think through, or we're going to write out all the factors of AC. After we do that, we're going to identify which factor pair sums up to B. So that means we're going to look at all of those pairs of numbers that multiply to AC, and we're going to figure out what they all add up to, and one of them is going to add up to B. And that's the one that we're going to use. After we do this, we're going to take that factor pair. So we're going to take those 2 numbers and we're going to substitute it back into the quadratic. So if we look at our examples up here, so right now I'm looking at this example compared with our standard form. So the only difference between these two is that bx term in the middle is broken up into two different terms for our grouping. And so that's what we're going to do. We're going to take our two factors and we're going to break up our b into those two numbers. So we're going to substitute our factor pair into the quadratic for b. Then once we do that, our final thing that we're going to do is we're going to factor by grouping. So this is what we've been doing. You've had a lot of practice with this. This is the simple part. So let's go ahead and do an example. So our example, and we're going to follow these 4 steps as we're doing this. Our first step is identify A, B, and C for this quadratic. So my A is 5, my B is 18, and my C is 9. So that makes my AC 5 times 9, which is 45. My second step now, I'm going to come over to this t-table, and I'm going to figure out which two numbers multiply to 45, to my AC. So I'm going to just write out all those factors. I have 1 times 45, 3 times 15, 5 times 9. And then after that, it would just repeat 9 times 5, 15 times 3, and 45 times 1. My next step is I need to figure out what those add up to. I'm trying to get it to add up to 18. 1 times 45 is 46. That's not going to work. 3 times 15 is 18. So that will work. And then just so that we see that that's the only option, 5 plus 9 is going to be 14, which will not work. Once you get to this spot, though, you can stop. You don't need to keep going. Our final step is we're going to substitute the 3 and the 15 in for the 18, and then we're going to factor by grouping. So I have 5x squared plus 3x plus 15x plus 9. So notice that this is the same thing. It does not matter which order I put those in, because at the end of this, I'm going to end up with the same answer. So I'm going to factor this out. So I'm going to take an x out of my first two terms. I'm left with 5x plus 3. I'm going to take out a 3, and I'm left with 5x plus 3. So I have 5x plus 3 times x plus 3. And that's it. This is factored out now. Let's go ahead and do the second example together. So this is on the back of your paper. The first thing we're going to do is we're going to identify our ABC and then our AC. So my A is 12. B is negative 36 because you have to pay attention to the sign in front. C is 15. And then AC is 15 times 12, which is 180. So my AC is 180. So I'm going to come over here to the side. I'm going to make myself a little t-table. I need two numbers that multiply to 180 and then add to negative 36. So now I have a negative thrown in there. So if I'm thinking about two numbers that multiply to a positive, I either need to have a positive and a positive or a negative and a negative. And then if I need two numbers that add to a negative, I've got to have some negatives in there. So the two numbers that I choose both have to be negative. So as I'm going through my factors, I'm going to have negative 1 times negative 180. I'm going to have negative 2 times negative 90. Negative 3 times negative 60. Negative 4 times negative 45. Negative 6 times negative 30. And I'm going to pause for a second because I notice that negative 6 plus negative 30 is negative 36, which is what I'm needing. So these are my factor pairs. So I'm going to substitute negative 6 and negative 30 into my quadratic expression. So I have 12x squared minus 6x minus 30 plus 15. For my first two terms, I'm going to factor out a 6x, and I'm left with 2x minus 1. For my second two, I'm going to have to factor out a negative 15, and I'm left with, that should be a 30x, positive 2x minus 1. And so I have 2x minus 1 times 6x minus 15. And that's my final factored answer. Go ahead and pause this video and try the next example on your own. And then once you're done, you can play the video, and I'm going to talk through this problem, and you can check and see if you're right. So for this next problem, my A is 3, my B is negative 11, my C is negative 20, and so my AC is 3 times negative 20, which is negative 60. So now as I go over here to work out my t-table, I need two numbers that multiply to negative 60. So I'm going to have a positive and a negative. And I need two numbers that add to negative 11. So if they add to a negative, then that means the larger one is going to be negative, and the smaller one will be the positive. So as I go through and think through my terms, I'm going to have 1 times negative 60, 2 times negative 30, 3 times negative 20, 4 times negative 15, and I'm going to stop right here because I notice that 4 plus negative 15 is negative 11, which is what I need, so I found my factors. So I have 3x squared plus 4x minus 15x minus 20. And when I take out that common factor of my first two terms, it's x, so I'm left with 3x plus 4. And when I take out the common factor of my second two terms, I need to take out a negative 5, so I'm left with a positive 3x plus 4. And so my final factored form is 3x plus 4 times x minus 5. The next problem, we're going to do the same thing, except now we're going to actually solve it. So we've already done this before. We're going to take it to this last spot here, and then we're just going to take that a step further. So we're going to take that and we're going to set each binomial equal to 0, and we're going to solve the binomial. So on this next problem, we have some numbers on both sides of the equal sign. So we need to get those both over on one side of the equal sign before we can do anything more. So I have 8x squared minus 8x, but then I need to subtract that 2x minus 1, and then I need to subtract the 2. Now I need to go ahead and combine all my like terms. Even though I have two x's in the middle here, I don't know that those are the right numbers. I don't know that those will actually work, so I still need to go through this AC process. So I have 8x squared minus 10x minus 3. So I know that my A is 8, my B is negative 10, my C is negative 3. So my AC is negative 24. I'm going to make my t-table over to the side. I need two numbers that multiply to negative 24 and add to negative 10. Well, negative 24, that's going to be a positive and a negative. My larger number needs to be negative because of my negative 10. So I have 1 times negative 24, 2 times negative 12, and I'm stopping here because I realize 2 plus negative 12 is negative 10, which is what I need. So I'm going to go ahead and use my 2 and my negative 12, and I'm going to write 8x squared plus 2x minus 12x minus 3 equals 0, because now I have this all set equal to 0 because of that equal sign there. And I'm going to continue going through and solving or factoring this by grouping so that I can solve the equation. So my GCF of these first two terms is 2x, so I'm left with 4x plus 1. My GCF of the second two terms is negative 3, so that I can have a 4x plus 1, and that's all equal to 0. So I have 4x plus 1 times 2x minus 3, that's equal to 0. I'm going to set each of those binomials equal to 0. And then I'm going to solve each of them individually. So I'm going to subtract a 1 over, so I have 4x equals negative 1. And I'm going to divide by 4 to get x equals negative 1/4. And then I'm going to do the same thing over here. I'm going to subtract a 3, so I get 2x equals negative 3. I'm going to divide by 2 to get x equals negative 3/2. And so notice that I have two answers, and my largest exponent is 2. So this is a two-term, or this is a second degree, and I have two answers. We have just one more problem left. Once again, go ahead and pause this video and see if you can work this one out on your own. Once you've got it, play the video and see if you're correct. My quadratic is already in standard form, and it's already equal to 0. So I can go ahead and see that my A is 1, my B is 3, and my C is negative 18. So my AC is actually just negative 18. So when I make my t-table, my two numbers need to multiply to negative 18 and add to positive 3. So I have 1 times negative 18. And actually my larger number needs to be the positive since my B is positive this time. So I have negative 2 times 9, negative 3 times 6. I'm stopping because I see negative 3 plus 6 is positive 3, which is what I need. So I'm going to write that into my quadratic over here. I have x squared minus 3x plus 6x minus 18 equals 0. So I'm going to factor out an x, so I get x minus 3 plus 6 times x minus 3. So I get x minus 3 times x plus 6 equals 0. I'm setting each of those binomials equal to 0, and I'm solving them. I need to add a 3 to get x equals positive 3, and I need to subtract a 6 to get x equals negative 6. All right, that is the last of these notes for this section. Go ahead and work on your homework and make sure you get it graded. We will continue to add on to this throughout this unit, and we're going to learn more and more ways to factor.